Alright guys, today's video is on trigonometry, which sounds very stressful because the word trigonometry is a big word, and it just sounds like a scary thing. But basically our goal is to understand what these three things are: sine, cosine, and tangent. They're going to be some of the most useful things you'll learn throughout math, honestly. And a lot of people in the beginning, they call them sin, cos, and tan, because that's what they say on the calculator. That's how you abbreviate it. So they're actually said sine, cosine, and tangent. And they are ratios. So the basic idea is, if you were to, let's say sine is kind of like taking the square root of something, or cosine is almost like taking something and squaring it, and tangent is almost like taking something and dividing it by 2. So you're taking some number and you're putting it through a process. It's a function. It does something to a number. But these x's, whatever goes into them, and these are just examples, so these aren't actually useful, but I'm just trying to show you what's happening. Something goes into sine, and sine processes it. It's a machine, and it spits out something else. So that's always going to be sine of some angle, and we use theta for an angle. So this is an angle. And what's going to come out is a fraction. So something over something. All right, so that's basically what's happening. We're going to use trig to find the missing sides of a triangle. It's going to be pretty helpful. We can use it in situations where we can't use Pythagorean. We only need one side to use it. All right, so trigonometry can be used to find sides, I guess, side lengths for can be used to find side lengths for
Will the following students please report to the Media Center? Olivia O'Clair.
So it can be used to find side lengths. Even if you only have one side, you can find another side. So you're going to be able to find, BC, this right here, or this right here, or this right here. Different side lengths. You don't need to put x, y, z on your paper. Also, if you have two sides, you can actually find angles using trig. And we won't do that today, but you can actually find angles. So just to clarify, this is trig, and I'm going to call this just 1a, so that your notes packet will say this up here, trig 1a. That's the correct video that we're watching. So let's talk about it a little bit. Let's just define these things. So whenever you have a triangle, that's a right triangle, so that's important, and you have a right angle in it, that's important, the following is going to be true for A. So A, I'm going to put a little arc here so you know which angle I'm talking when we're talking about this angle, and oftentimes we will denote A, instead of using letters for angles, we'll start using Greek letters for angles. So isn't that going to be fun? So instead of using A, B, and C, or X, Y, and Z, we're going to use theta, and someday, like probably phi and gamma. You won't really see that in high school. So theta represents an angle. In that way, you know if it's a Greek letter or a weird letter, it's automatically an angle. That's kind of a general rule of thumb. So sine of A is going to be, whenever you do sine, and they're all different, sine is going to be opposite over the hypotenuse. Let me write it out this time. So really, if I say sine of this angle here, if I was to say sine of that, you need to go across the lake. See how this is like a lake and you're over here? You've got to go all the way across it to the other side. That's the opposite. So this is the opposite. Obviously, this is the hypotenuse. We know that. And if you're not going across the lake, you're just walking along the shore, but you're not in the hypotenuse, of course. That's called the adjacent. Okay, so those are just three words that you're going to want to know. Opposite is across the lake. Hypotenuse, I think you know anyways. And adjacent is the leftover one, which is also right next to the angle. And not the hypotenuse. So if we were to go opposite over hypotenuse in this case, we don't know what this is, but we know BC is the opposite. We can see over here that BC is the opposite side. So this would be BC, whatever that is, divided by the hypotenuse, which is AB, whatever that is. So if you took those things and divided them, that would be the sine of the angle. Okay, so let's take a few minutes here and try a couple different ones. So in addition to the sine, there's also the cosine. And cosine stands for adjacent over hypotenuse. And I'm just going to start abbreviating now. So cosine stands for adjacent over hypotenuse. And I'll not abbreviate all the way yet. Adjacent over hypotenuse, which in this example is AC for the adjacent right here, divided by AB. Don't make this more than it is. I know it seems kind of weird, but you're just going from the angle and you're dividing two of the sides. And I'm telling you which one it is depending on whether you have sin, cos, or tan, sine, cosine, or tangent, to say it correctly. So tangent is going to be opposite over adjacent. I'm just telling you that that's how it goes. And sometimes we don't even write opposite. We just get really lazy and we write O over A, opposite over adjacent. But I'm going to write that just because this is an A. And we go to the opposite side, that's BC. And we go to the adjacent side, that's AC. And that's how we'd find tangent. So there's kind of a lot going on there. What you might wonder is how you're going to remember this. So this isn't on your notes paper, but you might think, how will I remember all of these trig ratios? And the older frog is saying to the younger frog that he uses so, ka, toa. So, ka, toa is helpful because it's telling you that sine, right, is equal to opposite over hypotenuse. Opposite over hypotenuse. Then it's telling you that cosine is equal to adjacent over hypotenuse. So cosine, oops, so ka toa. Cosine is equal to adjacent over hypotenuse. There's the C for cosine. It's a memory mechanism. And then tangent, running out of colors here, but tangent is equal to opposite over adjacent. Opposite over adjacent. So ka toa. If you look here again, if this is the angle, okay, this right here is the angle, same thing here. If you're going from the angle and you go across the lake, all the way across the lake, that's the opposite. The hypotenuse is, of course, pointed to by the right angle and the longest side, and the adjacent is the one left, which is right next to the angle. So that's how you remember things. So let's go back and just try to answer some of these right here. I'm going to give you some examples like the ones you're looking at. So you're looking at a couple examples there, and those are going to be your now you tries. Okay? But I will try to help you with a different one. So find sine of, I guess, angle A, and then also we'll find cosine of angle A. Okay. So we're going to draw a triangle. We'll make it look like that. Okay, let's make this 3. Let's make this 20. Let's make this 35. I don't know if that satisfies the Pythagorean theorem, so be aware that I'm just making this up. Let me, just because I feel like I'd be doing you a disservice, let me make it satisfy the Pythagorean theorem. 5, 12, 13. Okay? So now we have all of that, and we need to know what everything is. So this is A, and this is B, and this is C. What is sine of A? Well, sine of A is going to be so ka toa. So if it's so ka toa, we're going to use so, and we're going to take the opposite of A, and we're going to divide it by the hypotenuse from A. So go across the lake, that's the opposite, 5, and then the hypotenuse, and this is your answer. Sine of A equals 5 over 13. So that's kind of where we're at this point. Sine of A is literally equal to 5 over 13. So now let's talk about the cosine for a minute. So take the cosine of angle A. So cosine of A is going to equal, and now we can't use so in this situation, right, because it's cosine, so obviously we're going to use ca. And we're going to use adjacent over hypotenuse. So in this situation, we're going to go to angle A, of course. This is our angle here. We're going to go adjacent, which is right here, not the hypotenuse, the smaller of the two. So adjacent is 12. We're using this one. Hypotenuse is 13, and that's our answer. Cosine of A is 12 over 13. So basically, you're going to go to your angle. You're going to identify your opposite, your hypotenuse, and your adjacent. You can write them on as soon as you have the angle if you'd like. And then you are going to basically just divide. Use so, ca, or toa to do it. So that's really what you're going to do. So I want you to do now you try examples 1 and 2. So now you try examples numbers 1 and 2. So I think that's this triangle. I'm just going to do a real rough sketch of it, right? So you're doing that one, and then you have this one that looks kind of like this. Terrible drawing of it, but just quickly giving you an idea. Okay. And what you're doing is you're finding the sine of A, the cosine of A, the tangent of A, and then you're finding the sine of B, the cosine of B, the tangent of B. So there's actually 6 questions within each question, but they go pretty fast. So that is what is happening. Let's move on and do a little bit more with trig. So ca, toa is going to help you a lot. Oh, so here are those 2 examples, okay? So make sure you're doing a few different things. You're going to do sine of A, cosine of A, tangent of A, and then you're going to do sine of B, cosine of B, tangent of B. And these are all going to be answers. Why don't I go through and just give you a quick help with that. And then you're going to do the same thing over here. So I'm just going to think about so, ca, toa. So sine is opposite over hypotenuse. So I'm going to go opposite. And then I know this is the hypotenuse. So that's going to be 2 over the square root of 13. And then let's do tangent of B. Well, I want you to be aware that now if I go to a B, everything is kind of changed once I go to B, because now I have to think about a different adjacent, a different opposite. So tangent is toa, opposite over adjacent, opposite over adjacent. So I'm going to go from this opposite, which is 3, and adjacent is not the hypotenuse, not this way, but this way, so it's 3 over 2. And that's the answer to the top one here and the bottom one here. You try the 4 in the middle and then do the same thing, 6 questions on this one. Okay? So pause the video, give that a shot. And actually, we're going to wrap up this video here. So basically, all you're doing is using so, ca, toa to write the ratios in this video. I will see you soon. Make sure you do all of those problems, please.